All right, so let's start off by looking at the equation and finding values of x and y that would satisfy it. Can you find the values of x and y that satisfies x squared plus y squared equal to 5 squared? Give me some numbers that satisfy this equation. Something squared plus something squared equal to 5 squared. Give me something. Yeah? 3, 4, 5, right? So 3 squared plus 4 squared equals to 5 squared. But if that's true, then 4 squared plus 3 squared will be 5 squared as well, right? What else? Can you think of any other examples? Yeah? 5 and 0, yeah. 5 squared plus 0 squared is 5 squared. And you can also switch them. Now, because negative squared to positive, if this is true, then negative 3 squared plus 4 squared would be 5 squared as well, and then you could also have 3 squared plus negative 4 squared equal to 5 squared. All right? And then you can fill a few more just by taking negatives of these things. So if you were to draw the graph of this picture, this equation, draw the graph of this equation, you just need to find a pair of numbers that satisfy it. And we just found out that 3 and 4 works, 4, 3 works, and then you can have any combination of the x and y. So for example, you can have x's as negative, or instead have y as the negative, or you can also have both x and y as negative. So these are all possible. In addition, you could also have x, y as 5 and 0, so it could be 5, 0, 0, 5, negative 5, 0, and 0, negative 5. Okay, so we identified like 12 different points on this graph. And let's use them to see what the graph would look like. So if you do 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5. There'll be negative 5 here. Then 1, 2, 3, 4, 5, negative 5. First of all, these points, 5, 0, 0, 5, negative 5, 0, and 0, negative 5 are points on the graph because they satisfy the equation, right? And what about 3, 4? You have 3, 4, so it's over here. And 4, 3 as well, so there's another one here. Negative 4, 3 is on the graph, and 4, 3 is on the graph as well. Negative 4, negative 3. Negative 3, negative 4. And then 4, negative 3, and 3, negative 4. So these are the 12 points that we found out that they satisfy this equation. Now you can start plugging in more numbers. For example, if you have x as 1, then you can solve for y by subtracting 1. 5 squared is 25. 25 minus 1 is 24. So y must be square root of 24, or minus square root of 24. Square root of 24 is 2 times square root of 6. It's about 4.8 something, I think. So you can definitely have like 1, 4.8 or 4.9, something like that, to give you another point. So you can plug in other points, and as you plug in more and more points, what kind of graph would you get? Can you guess? It will be a circle, right? If you connect all these dots, okay, I didn't draw it very well, but it's a circle. Okay, it's a circle of radius what? 5, right? Because this distance is 5. It's a circle of radius 5. Is that good? Okay. Now, if you're convinced that x squared plus y squared equal to 5 squared is a circle of radius 5, now guess what this would give you? X squared plus y squared equal to 1. It'll be another circle, you would guess, right? Now, would it be a bigger circle or a smaller circle?
Smaller.
It'll be a smaller circle, right? Can you guess what the radius of this circle would be? It'll be 1. Yeah, that's a good guess. Because over here, you can just put 1, 0, 0, 1, negative 1, 0, 0, negative 1. These are the 4 points that would satisfy this, right? Negative 1 squares to positive 1, so 1 plus 0 will give you 1. So this definitely satisfies it. Once you know that those 4 points satisfy, here's 1, 0, here's 0, 0, 1, here's negative 1, 0, here's 0, negative 1. And the circle must be passing through these points. So what's the radius? 1. Okay? So that's how you get it. Okay, now the reason I'm bringing this up is because I want to talk about transformation of graphs. And circle equation gives you a nice way of thinking about transformations. So let's think about transformations of graphs by working with circles. So next thing that I want you to think about is, what is the graph of x over 5 squared plus y over 5 squared equal to 1? So what's happening from here to there is you're replacing x. It's replaced by x over 5. And y is being replaced by y over 5, right? If you took this equation, you replaced x by x over 5 and y by y over 5, you'll be getting this equation. Now the question is, for this equation, would the circle become smaller or bigger? Would it? Same? Okay. That answer is wrong. It's different, okay? So how many of you go for bigger? How many of you go for smaller? Okay. Well, more people are thinking that this is going to get smaller, but no, actually, yeah, it gets bigger, okay? It gets bigger, and this is going to be a recurring theme for manipulating equations. So there's a way to come up with a new equation by replacing variables just like this, okay? And there's a principle that works in any such case. So overall principle that will be true is that if a variable is replaced by another, by some operation done to the variable. So the operation that I'm thinking of is like you could divide, or you could add, or subtract, or you multiply. You could also negate. These are the things. Those are the operations done to the variable. The effect on the graph will be opposite. Okay, it will be the opposite. So if you divide by 5, well, if you divide a number by 5, of course, it gets smaller. However, for the graph, it will do the opposite. So instead of shrinking by 5 times, what do you think is going to happen? It's going to expand by 5 times, okay? It's going to expand by 5 times. Yes? Oh, okay. Yeah. All right. Yeah, the principle is that it will go the opposite way. So it will expand in the x direction by 5, and it will expand in the y direction by 5. Okay? So imagine that you have a Xerox machine, you put the picture, and then there's like a times 5 button, right? So this circle of radius 1 is put in, you Xerox it, and now comes the 5 times enlarged one, okay? Question. Therefore, what is the radius of this new circle? 5, right? Oh, but wait, we just did a radius 5 circle. What was that? It's this one, right? So what's happening? Does that mean this is same as that one? Why are these two the same? Can you see it?
Because if you was to switch the 5 from the other side and equal side,
that's right. That's right. So look, if you started with x over 5 squared plus y over 5 squared equal to 1. How do you square a fraction? The top and bottom separately are squared, right? You get x squared over 5 squared plus y squared over 5 squared. That's how you square a fraction. They separately, top and bottom, get squared, equal to 1. And now do the thing that I usually like to do. I just hate denominators. I try to get rid of them, right? So I'm going to multiply each side by 5 squared, which will cancel the denominators away. And look, what do we end up with? What we started with, right? So indeed, we see that this overall principle is true. If you divide by 5, you end up getting an enlarged circle. Yes?
So we get a question whether the denominator is different. We got to find it out.
So can we get a different denominator is the question. I don't know. Maybe I could. But it's okay, so actually that's a good question. Let's think about the following one then. So say we agree that x squared plus y squared equals to 1 is a radius 1 circle. Radius 1 circle. My 1 looks funny. 1 circle centered at the origin. The origin. What's the origin? Origin is 0, 0, right? What will be the graph of, say, x over 2 squared plus y over 3 squared equals to 1? What's the graph of this? What do you think? Okay, so what does x over 2 do? Yeah? No. I'm not asking you for a number. I'm asking you for the picture. Okay, what's the shape of the picture you get when you graph this? Okay, so what does x over 2 do to the graph? You expand by 2, right? What does y over 3 do to the graph? It expands 3 times in the y direction, okay? So imagine that you have a you have a circle, right? And then you let's say this is a rubber pad, and then you put some kind of a stick on this side, and then you just try to expand it, right? Like like a gum. So that this circle is going to stretch twice, right? And then do the same thing in this direction. Now you do it even further and make it 3 times. What's the shape you get? It'll be an oval, right? Yeah. It'll be an oval. So the shape you're going to get will be like you have 1, 2, 3, because the original one was 1. The picture is going to be like this circle is first stretched twice, so that these 2 points are going to stretch twice, and then these points are going to stretch 3 times. So you end up with a curve that's like this, something like an oval, right? An egg or a football or something. Yeah. So that's what you're going to get if the 2 numbers are different. Okay. Now, what I want you to be able to do is I'm going to throw you a bunch of different kinds of equations, and you have to look at it and use that principle to determine what the graph is. Okay, so let me start over here. Example 1, sketch. Say x minus 2 squared plus y plus 3 squared equals to, say, 16. Oh, and when we do this, let's agree on one thing. We did x squared plus y squared is equal to 1. But in general, if you have x squared plus y squared equals to r squared, what will be the radius of this circle? If it was 1 squared, it's 1, right? But if it's r squared, it's going to be r, right? So it'll be radius r circle centered at the origin. Okay? So if you're asked to sketch this graph, what you do is first, you think about the things before replacement. So this is like x minus 2 replacing x in that equation, and then y plus 3 replacing this y, right? X is replaced by x minus 2, y is replaced by y plus 3. So if you take that viewpoint, before replacement, this is what you got. Now this one has radius what? What's the radius? What's the radius? Huh? 16 is wrong. 8 is wrong. 4 is right. Why? Why? Because 16 is 4 squared, right? So the radius will be 4. Okay? So it's a radius 4 circle, according to this, what we just agreed on. Now, it's very easy to see if you take the viewpoint of plugging in values. See, if it's 4 squared on the right side, if you plug in 4, 0, it's going to satisfy it, right? So 4, 0, 0, 4, negative 4, 0, 0, negative 4. Those are the 4 points that's going to satisfy this equation. You place them on the plane, you see that the circle that would go through all those 4 points must be radius 4. So it's kind of obvious if you just punch in the numbers. Yes? Now I'm going to put the x minus 2 and x plus 3 in there, okay? So this is so first of all, this is going to be a circle of radius 4, because 4, 0, 0, 4, negative 4, 0, 0, negative 4 satisfies this equation. Okay. And this is another reason why I stress mental math. If you're fast with mental math, what I just said is very obvious. 4 squared is 16, plus 0 is 16, and that is equal to 16. So good, 4, 0 is the point on here. So just quickly do that, then it'll just make sense. Okay? You don't have to try to memorize that this is radius r. It just makes sense. Okay, now what we are going to do is I'm going to replace x by x minus 2 and y by y plus 3. And as you do that, we're going to use that principle that the graph will behave the opposite of what you do to the variable. Okay, so if you subtract 2 in the x, that means, yes?
It's going to increase by 2.
In the x coordinate, which means you're going to move which direction, right or left? Right, right? If you subtract 2, it's going to move right. Now, what about this? If you add 3 to the y coordinate will be decreased by 3, which means it's going to go down by 3. Is that okay? So we know that this is going to move right 2, and this is going to move down 3, so that you initially had this circle of radius 4. Okay, and then maybe -3 here, +3. And this center now is going to move 1, 2 steps right, and then 1, 2, 3 steps down. So you're going to end up with a new circle whose center is right here. And that center is going to have radius of 4. So it's going to be like that. Okay, so this circle moved 2 steps right, 3 steps down, and this is the new circle. No, if it was x plus 2, then it will move 2 left, right? If x is replaced by x plus 2, this is going to move left by 2. Okay? If it's x to x minus 2, it's going to move right by 2. Okay? Y to y plus 3 would mean go down by 3. If it was y to y minus 3, then it's going to go up by 3. Okay? All right. Okay. Now, in example 2, let's now, instead of asking to graph, let's just ask for the center and the radius. So, example 2, find radius and center of x minus, let's say x plus 5 squared plus y minus 4 squared equals to 3. Okay. First of all, what is the radius? What's going to control the radius here? The 3 is going to be related to the radius because the plus 5 and minus 4 just makes it move somewhere, okay? That's all it does. It just makes it move. And 3 is actually the size of the original circle before it was moving. Okay, so 3 really determines the radius. What is the radius then? 9 is wrong. 3 is wrong. Square root of 3 is right. Because think about what we did here. When we had 16, what's the radius? 4. 16 became 4, right? What's the operation that takes you from 16 to 4? Square root. If you do square root, you end up with 4. Square root of 16 is 4. So to get to the radius from this number, you have to take the square root. So therefore, radius would be square root of 3. Now, so that's the answer. Now, what will be the center? Well, see, this makes it move 5 steps left, right? And then this makes it move, what? 4 steps up. So before moving, the center of the circle was at the origin. that origin now moved 5 steps left and 4 steps up. What's the new coordinate of the center? -5, 4. So you see that the center is -5, 4. Okay, I hope that made sense, because now I'm going to make it harder. We're building up from basic things, so if you don't have a firm understanding of the basics, then what I try to explain further would be harder to understand. So now, example 3, find the radius and center of, let's say, x squared minus 8x plus y squared plus 6x plus 1 equals to 0. Okay. So let's think about this. Oh, 6y. Keep doing that. 6y plus 1 equals to 0. Okay, that looks a bit different than previous ones, because if you look at the previous ones, you had something squared equal to a number. Okay, that means we won't be able to tell what the center and the radius is unless we change from here to there. Now, how do I go from here to there? What's the method? Yes? Huh? Distribution. Not distribution. Anyone else? Yes? No, not. No, not. Yes? Huh? Complete the square. That's the correct answer. Yeah. So if we complete the square, then these two are going to look like that, with something on the right side, right? And it's a wonderful question to try, because you're going to have an exam on completing the square next week anyways, right? So you should really try this out, okay? But let me first do this for you, and I'll leave the next one to you. Try to do the next one, okay? All right, so how do we do the completing the square? So first you move the constant term to the right side, right? And then when you complete the square, I mean, if you do it the way I taught last week, you would still remember it and it will just look easy. But if you still couldn't understand what I was explaining, I'll just give you a simple algorithm, which is like to complete the square. The algorithm for complete the square is take coefficient of x, okay? Take 1/2 of it, square it, then add to both sides. Yeah, that's the simple way of doing things, okay? It's not the best way to learn completing the square, because if you memorize this, it's going to only last you until your next exam, and then you're going to forget it again. And later in the class, you're going to realize you have to memorize this again, which is not a good thing. But, you know, it's a temporary measure. It works. Okay. So what are you looking at here? You have -8. So what do we do? Take half of -8. What's that? -4. You take the -4, and what do? Square. What's that? 16. So that means I have to add 16 both sides. Okay. Now, what about this one? How do you complete this one? Which number do you take? 6. What do you do with it? Take half of it. Yeah. Take half of the coefficient. Square that. which is 9. So you're going to add 9 both sides. And the result is that if you try to factor this, you'll see that, well, what are the two numbers that multiply to 16 and add to -8? -4 and -4. So this is going to be factored as x minus 4 times x minus 4, which is x minus 4 squared. Right? This works out. Plus, what about this one? What are the two numbers that multiply to 9 and add to 6? 3 and 3. So this is going to be y plus 3 times y plus 3, which means it's y plus 3 squared. Okay? Now what? You have -1 plus 16, which is 15. 15 plus 9 is 24. Okay? So that now looks more like our previous ones. Okay? We see that these are translations. It moves up or up, down, left, or right, something like that. And this controls the radius. What's the radius? Radius would be square root of 24. Now, 24 is 4 times 6. So you can think of this as 4 times 6 square root. But 4 is a square root. Square root of 4 is 2. So 2 times square root of 6 is what you get. Okay, so that's your radius. Okay, what about the center? It'll be moving 4 to the right and 3 down. So the new center will be 4, -3. Now, if you are taking the view of this overall principle, it's kind of natural to see why this would have the center as 4, -3. But if you're confused, another way to think about it is like whatever number you see, just negate it. You see -4, it will be +4. You see +3, it's -3. That's the. Try this together. So first, you take this number and what do you do? Take half. You divide by 2, and you square this. What do you get if you square this? Yeah, when you square a fraction, it's square both top and bottom, right? So it's going to be 3 squared over 2 squared, which is 9 over 4. What about -5? For the -5, -5 over 2 squared, which gives you 25 over 4. So these are the numbers that we must add. X squared plus 3x plus 9 over 4 for this to be completing the square, and then plus y squared minus 5y plus 25 over 4. And then this one should go to the other side, -1, and these should be added. So 9 over 4 plus 25 over 4. Okay? Is that okay so far? Okay. So now, this is a square of something. What is it? Square of x plus 3 over 2. Okay? Plus because this is plus and the square root of this is 3 over 2, right? So that's what this will be. This is 5 over 2 squared, so it'll be y and then 5 over 2 squared, but there's a minus here, so this is going to be a minus. On the other hand, think of 1 as 4 over 4, so that's -4 plus 9, which is 5. 5 plus 25, that's 30 over 4. Okay, so that gives us a form where we can read off the radius easily. What's the radius? It's the square root of 30 over 4, right? Which is square root of 30 over square root of 4. That's going to be square root of 30 over 2. That's the radius. And then, what's the center? Because it's plus 3 over 2, we say -3 over 2. Because this is minus 5 over 2, we say positive 5 over 2. So that's it. That's how you answer such a question. And all of this will be easier to understand if you know this overall principle. Okay. Okay, let's now move on to transformation of the parabola. For this, you need to know the following fact. Y equals x squared gives you a parabola whose vertex, this tip of the parabola is called the vertex. Vertex is at the origin. You can get that graph just by plugging in values into x. You plug in -2, -1, 0, and 1 and 2. -2 squared will be +4, so you plot -2, 4. Then you plot -1, 1, and 0 and 1, 1, 2, 4. At some point, you'll see that the graph is like that. But during the exam, you don't have that much time, so you'll have to memorize this. Okay, y equals x squared has this graph. Now, the good thing about your brain is that we human brains are evolved to be more visual than equations or words. Like human writing system is pretty recent. We're not used to that. Okay, maybe our spoken language is a bit older, but even before that, our visual systems were very important for our survival. Right? If we see something, we have to figure out if it's something yummy that we should chase and kill, or is it something vicious that we should run away from. If your visual doesn't help you with that, you're dead. Okay, so when it comes to visual things, we're much better at remembering. So if you remember that y equals x squared is this graph, it's probably going to stay with you for a while. Okay, so that's the graph. Let's make sure that we remember that thing. X squared has this graph. And then we're going to graph these parabolas using the same approaches. Okay. So the approach that we're going to do is example 1. Sketch the graph of y equals to x minus 2 squared plus 3. Let's think about this. Okay. Question. Original graph is x squared. And now we're transforming this to make it x minus 2 squared and then adding 3, right? So what are we doing? We're replacing x by x minus 2 and then adding a 3. And in order to draw the graph, we have to think about what these are doing. So if you replace x by x minus 2, what happens? Yeah?
It goes to the right.
Right 2. That's the overall principle, the opposite, right? If you replace x by x minus 2, it moves 2 to the right. So this is going to, let me write it here. This much is going to say move right by 2. That's what it's going to say. Now, what about this plus 3? What is it going to do? Yeah? It will move the entire graph up 3. Okay? Now, here's the confusion. Okay? It's actually going to move up by 3. But wait, I thought the overall principle was that if you replace, the graph would behave opposite. We added 3. Shouldn't it go down? And in fact, that's what some of you were trying to say, right? Yeah. Yeah. Huh? Okay, so one way to say it's not a parenthesis. Good observation. It's not connected with y. That's why. Okay. So plus 3 will move up by 3, and I want to say that this does not violate this overall principle. In fact, let's change the question, turn it upside down, okay, turn it on its head. So instead of trying to ask that, if you take y equals to x squared and then move right 2 and move up 3, what's the new equation? Well, if we take this principle, x has to be replaced by what? X minus 2 squared. That's same as before, right? But then y has to be replaced by what? Y minus 3. That's what must happen, right? Now, this is what I'm claiming that what you get if you took this graph, move 2 to the right and up by 3. But then the question is this same as that? It is, right? Why are these two same? Because if you move the negative 3 to the other side, or if you move 3 to this side, you get the same thing, right? So here's what's happening. If you think of this plus 3 as really minus 3 on this side, then indeed it is moving up, right? And when we do that, we're using the overall principle, right? But another way to think about it is that simply this plus 3 is not replacing a variable. This one is replacing a variable. What we used to have x there, and x is replaced by x minus 2. Am I replacing something here? No, I'm just simply adding a 3. Okay. In fact, the way I view this is I'm thinking of plus 3 as something added to a function. Is that okay? I'm adding to a function. So what really happens is that with the overall principle, there's also this plus what's done to the function will have same effect, not the opposite effect, same effect on the graph. Okay? So that's this extra thing that you have to understand. So if you add 3 to the function, it will move everything up by 3. Is that good? Yes. All right, so now what's the graph? You're taking this, you're moving. So you take this graph. Here's the vertex that's going to move 1, 2 steps right, and 1, 2, 3 steps up. That will be the new vertex. And this is the graph. That's how you think about it. Okay, example 2. Sketch the graph of y equals to 1/4 x squared. Okay, what would this do? Y equals to 1/4 x. Yes?
So 1 to the left.
No, when you multiply a number, it never moves left or right. So the one that makes it move left, right, up, down are plus or minuses. This is multiplied, so it's like one of those like shrinking or expanding stuff. Yes?
It's going to multiply by 4 vertically.
Well, okay, so you're saying the graph is going to expand 4 times in the vertical direction, but see, 1/4 is done to what? The function. So instead, what's going to happen? No, what's your opinion? Huh? Yes, it's going to shrink. It will be compressing 4 times in the y direction. That's what's going to happen. Okay. We're doing to the function. See, 1/4 is not multiplied to y. It's multiplied to x squared, which is the function. So another way to view it is a similar way, like how we thought about this plus 3. You can move the 4 to this side. If you do that, what happens? It's 4y equals to x squared, right? Then this is this case, right? You're replacing from y equals to x squared, you're replacing y by 4y. So what happens? It will compress by 4. Is that okay? Yeah. All right. So when you put this over here, it will compress by 4. Okay? So that's this extra thing. Okay. So that's one way to view it. Here's another way to view this. You can think of this as y equals to x squared over 4. After all, if you multiply anything to a fraction, that thing only gets multiplied to the top, right? That's how you multiply a number to a fraction. It only gets multiplied to the top. So it's x squared over 4. But x squared over 4 is x over 2 squared. Now, if you have y equals x over 2 squared, what's happening from y equals x squared to y equals x over 2 squared? X is replaced by x over 2, right? If you take that view, what's happening to the graph? What does that do if you replace x by x over 2? It expands 2 in the x direction, okay? So that's another way to think about it. So here's two ways to graph the same thing, which is this is the original graph, y equals x squared. And it's like taking this and stretching it, stretching the entire paper this way to make it twice. So all of these lengths from the y-axis is going to double. So that you're going to get that graph. Just like that, okay? You get a wider parabola. That's what you're getting. Yeah? But that will be like viewing it like this. You can also view it this way, which I said was to compress, right? So if you want to think of it that way, then think of it this way. Every point and the distance from the x-axis has been made as a quarter, 1/4. So it's like this will be the half, and it will be half of half. Doesn't look like quarter, but it's supposed to be. So over here, what's happening is like it's half of half. So if you take this graph and you compress it by 1/4, again, you get the same graph. Either way, you get the same graph, okay? And either way, the overall shape is going to be like, as you get something less than 1, the graph will be wider. Is that okay? You get a wider graph. Okay. Now, since that was a bit confusing, let's just make it as a fact and then move on. So here's what we're going to do. We're going to say that in general, y equals to a times x squared, right? If a is bigger than 1, this stretches in y direction. So parabola becomes pointier. Right? Yeah, it becomes sharper. It'll be like if you take this parabola and you stretch it this way, then it will be thinner, right? The parabola will be thinner. Maybe that's the way to, yeah, it becomes thinner. Yes, thinner. If a is less than 1, that's like contracting. You're pushing it, you're compressing it, right? So this compresses in the y direction. Parabola becomes wider. So given this, example 3, order the parabolas from thinnest to widest. Okay, and let's say you have y equals to x squared, you have y equals to 1/2 x squared, you have y equals to 5x squared, and you have y equals to 3x squared. Okay, so which one's thinnest?
Y,
Yes.
Y, 5x.
Yes, yes. So the answer is y equals to 5x squared will be the thinnest, right? And next is y equals to 3x squared, y equals to x squared, and what's the widest? 1/2 x squared. So as you go this way, if you draw all of these, this will be in the thinnest one, and then the next one is 3x squared, and then y equals x squared would be this one, and then y equals 1/2 x squared will be widest. That's what's going to happen. Okay. Now, we did a lot of things today, but if you think about what we've done, we really didn't learn much. So you could really say that what we learned was this general principle of transformation, plus the fact that y equals to ax squared is either large A thin, small a wide. That's what we learned. And then you also have x minus a squared plus y minus b squared equal to r squared. That's going to have radius, well, let's just say this is a, some number a. What's the radius? Square root of a, right? What's the center? A comma b is the center. This, that's all we learned, okay? So now let me just give you our final question for today. Let's try this one. Find the vertex of the parabola y equals to x squared plus, let's say, yeah, let's put something like 12x plus 17. Okay. And graph it. What should we do? How do you find the vertex?
Wouldn't you factor and then
You don't factor, no. How would you find the vertex? Okay, well, you start out by subtracting 17, but what would you do after that? It's either factor or what? What's the other one? Complete the square. And it must be the other one, since I said factors, no. You complete the square. What should we add both sides? What's half of 12? 6, and you square that, that's 36, right? So we're going to add 36 both sides. So y minus 17 plus 36 is equal to x squared plus 12x plus 36. And this now becomes a complete square. What is it? Square of what? X plus 6 squared, okay? And this left side, what's that? 36 minus 17 is 19? Yeah. So y plus 19, so you subtract to the other side, you get y equals to x plus 6 squared minus 19. Okay, what does this do? X plus 6. Moves 6 steps left. What does negative 19 do? No, down 19. Okay, yeah. This 19 is done to the function, so it does as is, same effect, okay? This x plus 6 is a replacement of x, so it's this one. It does the opposite. Okay? If you know that, everything will make sense. If you don't know that, it'll be really hard to understand what's going on. Okay? So it's like today's real lecture was about this. With many examples, we're trying to figure out what this meant, okay? So if you didn't understand it, please try to watch the video next time to make sure that you understood it, okay? All right, so therefore, what's the location of the vertex? It'll be -6, -19, because you went left by 6 and it went down by 19. So the origin went left by 6 and down by 19. That's the new vertex. And therefore, the graph is going to be, here's -6, and then here's -19. That's the new vertex, and it'll be like that. That's the answer. And you could do a little bit better. If you plug in 0, you get 17. So we actually know that this meets right here at +17. Okay. But that's not necessary. All right, that's all for today.